I remembered before your reminder. Okay, so the graph we did yesterday looked something like this. We studied the displacement graph, the displacement time graph, and the velocity time graph. There's some things that I want to tell you guys about that, but we're going to do that after this. So the first thing is this. This is our priority right now. Okay, so the thing on the y-axis was displacement, right? Am I right? Okay, let me check real quick. Was it the displacement or was it the velocity? LOL. Let me see. I think it was the velocity. Maybe. Yeah, it was the velocity. Thanks for correcting me. Yeah, it was the velocity. Okay, so the y-axis was velocity and x-axis was the displacement. Okay, now a simple way to do it. You know that we have some points. Now, this is our maximum velocity. We're going to call it plus Vm. And this is our maximum velocity in the opposite direction. This is minus Vm. We can also call it plus A omega or minus A omega. You know that maximum displacement is the amplitude. So plus A, and the maximum displacement in the opposite direction is minus A. Now we did something yesterday. Let me make this smaller. Let's make a pendulum real quick. Okay. So if this is my pendulum, let me move it a bit here. Okay. If this is my pendulum, I know that there's two spots in my motion. The middle spot is called the mean position, the dotted line. So this dotted line, this is mean position. This is the mean position. These are just the things that you're supposed to know. And I know that this is my peak position, the place you release your pendulum from. So this is the peak position. Okay, so yesterday, and this is also the peak position. So peak position. Now, yesterday we did some things. Can anyone remind me, what is my displacement at peak position? What is my displacement at peak position? Exactly, my displacement is the maximum. So x is max. And what is my velocity at peak position? Exactly, my velocity is 0. Now, that leads us to the first point. Okay, so displacement maximum, well, I only see one point here. So this would be peak position. And I think my velocity is definitely 0 at this point, and my displacement is the maximum. So I think this is our first point. We can use an orange color. Okay, so this is our first point. Now let's look at the mean position. Okay, so what is my displacement at the mean position? 0, yes. So yeah, so it's also it's gonna be 0, right? And what is my velocity? What is my velocity at the mean position? Exactly, it's gonna be the maximum. Now, I know one thing, that velocity maximum, it's a very general thing, right? So velocity can be positive and it can be negative. So it's going to be maximum for both directions. I'm going to explain what I mean by this. But for now, we're going to mark 2 points. So velocity is maximum at 2 points, this point and this point. Now, let me tell you one really cool thing. Okay, so we made 1 point. So why did I mark 2 points here? Isn't that kind of different, right? Now, there's a very interesting reason for that. Let's make an arrow. So check this out. I am moving towards the right. And I know that at mean position, velocity is maximum, right? But isn't it true that I can also move like this and I can move like this? So I can move like this and this. So this means that in one oscillation, there's going to be 2 times that I'm going to pass the mean position. This means that I'm going to have plus V. This is going to be my plus V max. And let's say this is going to be my minus V max, just to explain you why we're going to have 2 points. And in case you still have that confusion, remember we derived the formula. So we was, at mean position, we was plus minus a omega. So using the formula yesterday, this is the actual reason. So I think this is the better reason, because at mean position, we calculated that our velocity is plus minus a omega. So this is the cooler reason, you could say. That's why I'm marking 2 points. Now, obviously, this is the only remaining point. Now you might wonder, okay, so if I just have to join these points, why don't I make the lines? But no, it's not going to be the lines because they are not directly proportional. So we have to show a non-uniform increase like this. So it's going to look something like an oval or a squashed ball. It's a weird shape, but okay, it's not symmetrical. Yeah, elliptical, I would say that's the better word. So it's going to look something like this. Okay, I guess that's kind of acceptable. It's going to look something like this. I hope everyone is clear about this. Does anyone have any kind of confusion related to this? If you have, you can ask me. Okay, does anyone have any kind of confusion in this diagram? Okay, great. Key, A stands for the amplitude. This is the amplitude. This is maximum displacement, okay? All right, so this is it for the graph. Now, I'm gonna place it aside. In fact, make this graph if you have not, and tell me when you're done, because we have to discuss something really cool now. It's gonna be a clarification for yesterday, and it's gonna be a new perspective. Okay, I'm waiting for the rest. Tell me when the rest of you guys are done. Okay, so I assume everyone is done. Let's erase this. Clear. Okay, now, yesterday I taught you something, and before teaching you, I clearly mentioned that it's for peak position. So tell me one thing. If I am doing simple harmonic motion, there's two possibilities, right? Either I am gonna release my pendulum from this point, which is my peak position, or I am gonna push it, I'm gonna start my motion from this point. So there's two possibilities. Either I'm starting at peak position, or I'm starting at mean position. And now the thing is, in simple harmonic motion, yesterday I told you guys that the formula for X, okay, can anyone remind me, what is the formula for X? Let's check your memory. Come on, guys, be amazing. Tell me, what is the formula for displacement? We did the graph yesterday, and it was a pretty elaborate explanation. Exactly, it's A cos omega t. Make sure your A is capital, because that's the amplitude, not acceleration. So it's A cos omega t. Now, for those who study physics, for those who do questions, they have seen a lot of times that sometimes the examiner or in the book, they have said that X is A sine omega t. Personally, when I was a student, by the way, please pay attention in this part because it's really important. When I was a student, I used to think, okay, didn't I learn that X is A cos omega t? So where did this come from? I mean, how in the world is my displacement A sine omega t? Isn't it supposed to be V is equal to A omega sine omega t? But the truth is, even for velocity, you're going to see that sometimes they say that velocity is A omega cos omega t. Well, there's a reason for that, and I'm going to tell you what the reason is. So for peak position, I made a graph yesterday, and I don't know if Abdullah is in this class, but he pointed out a very interesting point. Now, my teacher taught me exactly the way I taught you yesterday, and I think there's a reason behind why he made the graphs the way I made them yesterday. It's to avoid confusion. So if anyone gets confused, I'm going to tell you what's the way out. Now, I'm going to make the displacement time graph. Now, yesterday, I made a graph And I told you guys that displacement time graph is a cos curve, right? It starts like this, and that's my graph. And the formula for this graph was x is equal to a cos omega t. Now, I'm going to make a little diagram here just to give us an opportunity to visualize this. So let's say this is my pendulum, and I'm releasing this from the peak position, just for better understanding, right? Okay, so you know that at peak position, my displacement, it's maximum. That's why I'm starting from this point. And you also know that my velocity is zero. Now, I would like to introduce a very interesting concept. Can anyone tell me, has anyone in this class studied mathematics paper 3 before? Has anyone ever studied A2 math before in this class? You are studying right now. Have you studied the concept of trigonometry? Did you study differentiation? Like, if I have sine, I'm going to differentiate and I'm going to get cos, right? Now, I know that there's AS students here as well, and there's A2 students. So I'm going to teach this in a very general way. Now, Abdullah is in this class now, and the thing he told us is it actually makes sense. Now, let's make the diagram, the actual diagram for the velocity time graph. We're going to look at the gradient. Okay. Now, yesterday, I told you that the formula for velocity was, so velocity was a omega sine omega t. But there's just one thing that I didn't mention yesterday. Check this out. Yes, I know that the gradient is increasing here, but just as Abdullah said, isn't it the negative gradient, right? This is the negative gradient. All of us know that if our gradient is like this, it's obviously the negative gradient. So if the gradient is negative and it's increasing at the negative, and I know that x over t, change in x divided by change in t, that's my gradient, and that's also my velocity, right? So shouldn't my velocity be this? So if we actually make the actual graph, and I opened the physics book, Mike Crundle, and they had the same graph. But why did I teach you that? Because I wanted to avoid confusion. Now, I'm gonna tell you something really cool, and for those who study math, you're gonna understand what I mean. So this is velocity, this is time. Okay, now, those who study paper 3, you know that gradient is dx over dy. So in math, there's this concept, when I differentiate something, that's my gradient, right? So I can say that the gradient of this graph is dx over dt, and that's my velocity. Now, if it doesn't make sense to the ones who don't study math, no problem. I just want to tell you why I'm doing this. Now, you know that if I want to differentiate this right here, you see this? Now, this a omega thing, this sine omega thing, in A-level physics, we make it a lot easier. But for those who want to pursue physics in the future, you're going to be using differentiation. So when I use dx over dt, I am going to get a omega. Now tell me, those who study math, if I differentiate cos, what do I get? Is it going to be sine, or is it going to be minus sine? Exactly. This is where it all starts to make sense. If we do this by math, we're going to get minus a omega sine omega t. Now I understand why my teacher told us to make the graph like this, because he wanted to avoid this confusion. Because those who don't study math, and in physics, there's a lot of biology students, and they're not supposed to know this, but there's just no way to actually tell them this. Now, for those who study bio, I have a better solution for you. So according to math, we have just proved that for peak position, the actual equation is minus a omega sine omega t. Now, if you study bio, you can just follow the gradient way. Now let's check this out. My gradient is increasing here, right? But it's increasing in the negative, right? So that's why I am increasing my gradient in the negative side. Now, when you reach this point, my gradient starts to decrease. But it starts to decrease in the negative again because the gradient is like this, right? Now, you can see why it increases in the negative and then it decreases. Now, everything that's happening here is in the positive, and that's how we get this. Okay, I know it doesn't make sense to the ones who don't study math, but I have a better option for you. Now, there's something really cool that I'm going to tell you now. It's something that I told you at the start of the lecture. Why is it that in some places you see that x is also written as a sine omega t? Well, there's a reason for that. Because it isn't mandatory for us to start simple harmonic motion from the peak position. We can also start SHM from the mean position. Who said that it's always going to be peak position? Because we can start from the mean position as well, and we're going to move there, and then we're going to go back. I hope this makes sense. Now, tell me this thing. Okay, let me make the graph, the new graph for the displacement. Okay, if I make the graph, if I make the displacement time graph, it's gonna look something like this. Tell me. Now, if I'm starting from the mean position, is my displacement gonna be maximum or is it gonna be what? Exactly. If I start from mean, it has to be 0. Now, if I actually look at the other things, I am gonna get this graph. And that's how I get x is equal to a sine omega t. So now you know that displacement has two formulas. It has a cos omega t and it has a sine omega t. Because you can start from the mean position and you can also start from the peak position. Yeah. Okay, now let me tell you another cool thing. What if I want to differentiate this? What if I want to differentiate sine? Am I going to get minus cos or am I going to get cos? Come on, math people. Yes, Sabina, it makes a difference. Exactly. Now, check this out. So according to this, if I differentiate this for the math ones, it's going to be velocity is equal to a omega cos omega t. And that's why if I have the peak position, I get the negative sine graph. But if I have the mean position, we don't have this negative thingy. That's why my teacher didn't tell us this negative thing because it's gonna make a lot of confusion. So for the bio ones, I have an easier solution for you guys. Just keep the mean position one in your mind because it makes more sense. Now, we're gonna use the gradient method to get this graph, okay? We're gonna use the gradient method to get this graph. And by the way, a fun fact, if you open advanced level, A-level physics, you're gonna see that they only mention the mean position one. They don't mention this at all. Okay, now we know that at this point, I have a steeper line here. You know, I have a steeper line here, right? And my gradient, it goes down to 0. So my gradient is decreasing in the positive. My gradient is decreasing in the positive. So I can, confidently say, Abdullah, I don't think there's a need to explain this because it's just gonna confuse them. Trust me on that. I have tried maybe, but bio students are not supposed to know that. If they want to pursue physics in the future, that's up to them. But I'm sure they want to be doctors, so LOL. Okay. Now, exactly, it's fun, but not for everyone. Okay, so it decreases in the positive. Now check this out. My gradient becomes negative and it increases. So my gradient increases, but it becomes negative. And that's why I'm getting this thing. Now, let's move on to the next thing. So now you can see that from this point, I have the maximum. Check this out. I have the maximum gradient. but this gradient is negative. This is the negative gradient because it's a line like this. So it's the negative gradient, but it's the maximum gradient. That's why I have plus Vm, and that's why I have minus Vm. Now, if you look at the other parts, you are gonna get this. How did I get this? Check this line out. Now, my gradient starts to decrease, but it starts to decrease. Okay, no problem. Now it starts to decrease in the negative, and then it becomes 0. Now, when we're at this point, our gradient starts to increase in the positive again, and we get this line. So if there's bio students, I think this is the best solution for you because this one can get a bit complicated. Okay, now tell me one thing. Do all of you understand this graph? Does anyone have confusion in, converting the displacement graph to the velocity graph? Does everyone understand this gradient concept? You guys should know that at this point, gradient is 0. That's amazing. At this point, gradient is 0. And the steeper your line is, the greater your gradient is. The less steeper your line is, the lesser your gradient is. And if your line is like this is the negative gradient. And if your line is like this is the positive gradient. So all of you are supposed to know that. Okay, that's amazing. So note this down, and we are gonna start a new thing. Yeah, it's gonna be a new thing. It's gonna be a new concept. So get ready for that.
Hey guys, so I wasn't able to teach what I wanted to teach on Thursday, so I'm teaching the next concept, in the Monday's class. So you can skip to the next video. Thanks for watching this video.